name is Laura Parent, and I am an applications engineer in the upstream oil and gas industry. I work here in Marshalltown, Iowa for Emerson and specifically work with Fisher Controls. Today I have Brian Van Vliet with us on the line, and he is with one of our Emerson Impact partners. He works for Spartan Controls, which is in Western Canada. With Spartan, he focuses on environmental solutions. The topic of our quick talk today is on environmental compliance solutions. Before we get going, just a couple of housekeeping tidbits for everybody. Whenever you got on the line, you are muted on entry, just so we can limit any interruptions. Should you have any questions come up throughout the course of the presentation, please drop those into the Q&A section, and we can take a look at those and talk through some at the end. We will start off with a safety moment today. Today's safety moment focuses on knowing your exits. The best way in is not always the best way out. It's important wherever you go in life, whether that's at home, at the store, at your workplace, that you're analyzing your surroundings and know where any exits may be. Should an unsafe situation occur, you will be able to reach those exits a lot quicker and get out of danger in a more fast situation. To go through our agenda for today, we are going to start off with the why. Why are we here talking about environmental compliance solutions? We will then move on to a regulations overview so you can understand what different types of places are seen as far as regulations go for environmental compliance. We'll then get into our Fisher solutions. We'll start off with our Fisher low bleed instruments, talk through those so you understand those, go through our energy responsible tool, and we'll then transition over and talk a little bit about our Fisher valves and actuation solutions. To wrap it up, we will have a case study that really demonstrates the why we do this, and you can put some numbers and values with the transition over to environmental solutions. So the why. Why are we here talking about environmental compliance solutions? Well, first of all, there's always the government regulations. People are very familiar with Quad O, which is one we see here in the United States, and you'll get very familiar with me talking about the less than 6 scuff of steady state bleed rate. That's a key number. Keep that in mind throughout this presentation. That is what we are trying to achieve. Besides just the governmental standpoint, customers and companies as a whole are setting new goals and standards for their companies. So they have goals in place and you are trying to meet those. Other than those rules and regulations, there's then the operational cost savings that you have associated with that. Whenever you are outputting less, that means you're investing more into your process, you get more produced, and thus that leads to more money for you as the end user. At the end of the day, our goal is to take good care of the environment and have our emissions near zero or net negative. By net negative, I'm meaning that you are capturing carbon and putting it back into the production side of things. So you have less carbon going out than coming in, so then you would be net negative. A few key definitions that you will see me talk about throughout this course of the presentation. The first one would be fugitive emissions, and these are gases or vapors which we do not intend to escape to the atmosphere. So think about like an open-ended pipe. Not necessarily what we would expect or want, but if that is just open, it is allowing fugitive emissions to escape. Venting is whenever we have emissions designed into the product. So think, for example, the instruments I will be talking about later. Those have all been designed to specifically have a vent rate associated with them for the operation of the device. Steady state flow is the vent rate which is associated with the instrument when it is just resting. When it's not moving or operating, it's just in that one steady position. Transient's the opposite, where we are, that is when we're changing the output, and so we are moving the device. To get into the regulation side of things, Quad O is probably the most recognizable regulation we need to meet, and it was set forth by the EPA in the United States. Quad O comes from the Code of Federal Regulations 40, Part 60, Subpart 0000, and thus you get Quad O. Quad O implements new air quality regulations for the onshore oil and natural gas industries. And it's not a new concept. This has been around for quite a few years. The final amendment was put into place in September of 2013, so we've been meeting this for quite a few years. Where we as Fisher come into place with Quad O is in two different areas. First of all, we have the leak detection and repair, or LDAR, LDAR, you'll hear that said. And this applies to natural gas processing facilities, and it sets a max leakage per device. You cannot exceed 500 ppm. So this applies to all equipment like your valves and your pumps. Where we see it with valves is whenever it comes to packing. And later in the presentation, we will talk about our packing options we have available, which is compliant. On the other side of Quad O, we also have pneumatic controllers. And again, you'll see this number come up here at the less than 6 scuff, and that is the steady state consumption for production and processing. That needs to be less than or equal to 6 scuff. That's the key number. On the Canadian side of things, it's very similar to what the United States has already put into place. Looking at environmental and climate changes, you can see that over 50% of those emissions are from fugitive emissions as well as pneumatic devices. Similar to the United States, Canada, as the federal government, is implementing on January 1st of 2023 that all instruments operated on fuel gas need to be venting less than 6 scuff. There are a few provinces you'll see listed below that have moved that date up, so new wells need to be compliant by an earlier date, so just keep that in mind. Again, a very important number. Moving on to the instrumentation side of things, I'll first of all start with going through an overview of products that we have that do and do not meet that less than 6 scuff steady state bleed rate. First of all, we'll talk through some controllers, transducers, pilots, and positioners. On this slide, there's all of these are compliant and they meet that less than 6 scuff bleed rate. A couple of the ones you would probably see the most would include the C1 pneumatic controller, the IDA P100 transducer, and then the FieldView DVC 6200, which is our digital valve controller. On the level side of things, we have both pneumatic and electric solutions, which would meet the less than 6 scuff bleed rate. So from the pneumatic side, we have that 249 level, the L2 level controller, and the L2SJ, which is a level controller more focused for the natural gas industry. If you wanted to go completely electric and remove any types of emissions, we do have some electric options available with the L2E, with the E being for electric, and then our digital level controllers with the DLC 3010, 30,000, and 3100. In a lot of plants, you have probably been operating for quite a few years, so there's a good chance you have some legacy instrumentation in your plant. The instruments listed here on this page do not meet the less than 6 scuff steady state bleed rate. So whenever you are going in there to replace these devices, it's important that you keep in mind that these are no longer compliant, and you'll have to look at implementing one of our newer instruments, which does meet that less than 6 scuff steady state bleed rate. Now we'll get into a couple more specifics so you can see the impact it has on switching devices and upgrading. So here we have what is our original 4150, which is our controller. And with this, we had a board-on tube here in it, and that would expand and contract to hit this flapper, which would then open and close the nozzle. And you see here there is that exhaust point. There's also a secondary exhaust point here with the proportional band knob. That proportional band knob was a second exhaust point, and so you can see there's 2 paths that leads to exhaust. This gave us a steady state fuel gas emission of 54 scuff. When we introduced the C1, this eliminated the 2 different exhaust points and created this proportional band knob that was only mechanical. So then our only exhaust point was here at the nozzle. This took us from 54 to 5.8 scuff. Whenever you make that change, this will save you on average $1,000 per year by making that switch. So depending on where you're at, prices, that type of thing, this could be paid off. 18 months to 2 years is around probably the longer side of things to get this paid back. So it makes a huge difference quickly. To put it into more simple terms of the type of impact this has for the environment, replacing a 4150 with the C1 is the equivalent of removing 35 cars from the roads in the course of 1 year. So it's a very significant impact, not only cost-wise, but then from the environmental side of things. We then have our electro-pneumatic flow control. You can see here our old model, which was the 546. In the mid-2000s, we introduced the IDA P100 first-gen model, which then took us, the original 546 was at 39 scuff, and then we were down to 13. However, that's still not meeting our magic number of less than 6 scuff. So whenever we had all these Quad-O requirements come in, we created a second-gen model that took us down to 4.0. Along with the second-gen model, we had a retrofit kit we introduced, which we could implement to our first-gen models to make those compliant as well. As you can see, we have significant cost savings by switching to the lower bleed rate options. From the electro-pneumatic positioner side of things, I'm going to guess a lot of you are probably familiar with our DVC 6200, which is our digital valve controller. Originally, we had a 3582i, which gave us a steady state fuel gas emission of 31. With the DVC 6200, our standard model has a bleed rate of 29. However, we do have a low bleed relay available, and whenever we have that option, that will take us down to a fuel gas emission of 4.3 scuff. Now, should you have just a standard DVC out there and you want to retrofit it to make it low bleed, we do have that as an option available. And with that retrofit kit, it will take us down to that 4.3 scuff. Again, fuel gas savings were around that $550 per year mark. Significant cost savings, and it should pay for itself relatively quickly in probably 2 years or less, depending on where you're at. Now for the level control side of things, have quite a few different options here level-wise. With our original L2 SNAP option, we had a fuel gas emission of 16.2. We then introduced an improved relay, which took us down to 3.5. With the L2SJ, that is our level controller specific for the natural gas industry, we are down to 2.3. We also have a completely electric option available in the L2E with the Easy Drive, which means we will have no emissions altogether since it is completely electric. here's a chart which is super helpful and compares our traditional equipment versus the low bleed options. It goes through air consumption of both devices, the natural gas equivalent, and then your total cost per year and how much that will save you. So we have the 4150 pressure controller, and you can replace it with the C1, and we can go from 42 to 4.5 scuff and save significant cost over the course of that year. Depending on the costs and everything, $800 to $1,000 easily could be saved by upgrading these devices. You as the end user, we have created a tool for you to use to check out how energy responsible your devices are. The link is there at the bottom, super easy if you want to jot that down to look it up. And this tool allows you to be a consultant of sorts for your company. So it allows you to compare our Fisher devices, both legacy as well as new, and then competitive devices, and take a look at all of their qualities. You could take a look at, their steady state consumption, what their operational costs would look like, if they're compliant to Quad O. Lots of options available to visit and take a look at on this website so you can then make decisions, and it'll help spearhead conversations you will have with your Emerson Impact Partner. Flipping over to the control valve side of things, we do have a couple of options available. Like I talked about at the very beginning with the leakage detection and repair, the LDAR, that requires that we have a max leakage of 500 ppm. So with that, we have introduced our EnviroSeal packing. We've had that for quite a few years, and that is both compliant to that standard and gives us the ability to have reduced maintenance. The reduced maintenance comes from the fact that the packing is live loaded, so then you don't have to get in there and be tightening it and making adjustments throughout. The max leakage of EnviroSeal is 100 ppm. From the actuation side of things, we have our Easy Drive, which is our electric actuator assembly. And this eliminates the need for pneumatic air altogether by implementing this onto your assemblies. To give you a little bit more on the Easy Drive, we have a standalone option available in the 200L, and this can be mounted on Fisher products or competitive products. It has a max travel of 3/4 of an inch and has a max thrust of 750 pounds-force, so keep that in mind. And just keep in mind, this is also just from the Fisher side of things. If this doesn't work for your process or for your situation, Emerson has a comprehensive portfolio of electric actuation options. So talk to your Emerson Impact Partner, and they will be able to help you further with what we offer. To finally wrap things up, we will be going through a quick little case study. This was a case study Brian was involved with in Canada, and he was dealing with an end user in the upstream oil and gas industry from the production side of things. They came to Spartan and Brian with the goal of coming up with an effective solution to reduce the vented emissions from their pneumatic devices. In total, they had 443 pneumatic devices that were just venting natural gas as just part of their normal day-to-day operations, and they wanted to improve this. After analyzing the situation, looking at their pre-existing infrastructure, they decided that they would make the replacement of those pneumatic devices with IDA P100s. Now, some of them already in line were first-gen models, so they implemented the retrofit kit. The remainder they replaced completely with brand new IDA P100s. With this which they had a natural gas fuel savings of 103,000 Canadian dollars per year, which converted to the US dollars is around 80,000. That's significant cost savings. This is a great example of how they're trying to meet a company goal while also meeting government regulations and the large amount of cost savings that you can have by making some of these adjustments. To wrap it up, it's really best, I'll bring us back to the point from those first slides. We are trying to meet those government regulations like Quad O, which is the less than 6 SCUF steady state bleed rate. That is our goal, and we want to meet those regulations. Besides just the government standpoint, you also have from your company. You have directives, goals, and initiatives set into place that you need to meet. Other than that, there's also the operational cost savings. When you are letting less of your bleed out, you're able to put more into your process, you'll produce more, get more money for your company at the end of the day. Our goal is to have near zero or net zero emissions and be overall good stewards of our environment. So with that, that will wrap us up with this presentation for today. And so we can go ahead and take a look at some of the questions which came in. So there was a question about the bleed rates when we are referencing here and whether we're referencing gas as the motive force and not instrument air. Yes, that is correct. In this case, we're talking about natural gas as that force, and that is where a majority of these regulations are driven from, and why a lot of times this is way more prevalent in the upstream and midstream oil and gas side of things. Right. Do we have any other questions on the line? I'll make sure I didn't miss any. Let's look here. Oh, here we go. All right. I'll take a look at these. I think Brian was answering. Okay, there was a question of, will there be a copy of this presentation available to share? Yes, we will have this available here. It'll probably be in a few days. I think Nate may be sending out an email to participants. We'll have it posted on our website. So we'll make sure to get that out.
I'm kind of filling on that. So the presentation will be up and available on emerson.com here in probably, usually it takes a week or two to get it uploaded and edited to get out on the web. So we'll be here in a couple of weeks, and everybody who registered for the session, I'll make sure you get a link.
Awesome. Thank you, Nate. Brian, there's a question on here I think you would be able to answer better than myself about, is it possible to misadjust the Quad O compliant devices to bleed more than 6 SCUF? I know we talked about that the other day. Can you answer that a little more in depth?
Yeah, I can. So I would say a qualified yes. When instruments are operating as they should be, they will be compliant as is designed as a factory new instrument. I know in the case of a level controller, for example, we touched on the L2s or the 2680As or 2660As. Their published steady state vent rate alone is considered compliant. But as you notice in the table there were higher baseline vent rates. And what we're referring to in that case is a total vent rate. So it's really important to discern what type of volume that is if you have a measurement. If that's including actuator volume when it moves in the opposite direction, and the connecting tubing volume as well. But if I'm referring to the total vent rate of an L2, it would also include what's known as a transient vent rate that we defined up front. And so that is sometimes perceived as a steady state vent rate because it's happening in a resting position. And that's where it's really important to have maintenance of devices to ensure that they're still operating in what would be considered a factory new steady state vent rate. And if you maintain them, they will continue to perform there, but they do need to be maintained.
Awesome. Thanks, Brian. All right, let's see. Okay. Let me look here, sorry. Okay, Brian, you might also be helpful with this one about the, can you associate the air required for the bleed rate as an expense so that whenever you have less bleed rate, that would equal less compressor runtime, so you'd save money?
Yeah, absolutely. So what's really important to differentiate is that when we have vent rates of air, or we have vent rates of fuel gas or natural gas, propane, et cetera, that you may be running your instruments on, they each have different molecular weights, different specific gravities, and that will be impacting the vent rates. There's an ISA standard that refers to that impact, and often what we're seeing is that fuel gas will be venting at about a rate of about 30% more. And that's included in the energy responsible calculator on the website. So you can put in the parameters there. You can also identify what the cost of air would be, if that's compression power and the electricity associated with that form of compression. And so there certainly is a savings there to air. It just typically have the same magnitude of value. But absolutely, I was just reviewing for one of our customers here in Western Canada. They're actually running short on their instrument air header supply. They're finding that there was too much pressure loss in the system. So you can look at what all the use cases are. You can also look at where the pressure is being shed across different metering devices, elbows, etc. And if you can optimize or reduce there in the demand, then you may not need to have another large air compressor added to your plant site. Okay, now there's a significant capital saving, right? And so it may not be just the operational cost, but it's ensuring that the incremental capital costs of large assets is also potentially mitigated.
Awesome.
Brian and Laura, a couple of questions came over to me just on the chat line. So one of them is it possible for Emerson to come survey the plant and help understand the opportunity for savings or suggestions on improvements?
And I can take that one. So yes, absolutely. We're working with our local service company as well to do walk downs, and part of that work is like acoustic monitoring even as a measurement of loss. And I know here at Spartan too we have infrared cameras, and so we can be using infrared cameras to help see the little plumes that would be released, similar to what they'd be doing at upstream oil and gas sites when we're being Quad O compliant, right? So yes, absolutely, there are opportunities to help our customers achieve reductions, and I've been collaborating again with the service company to do such activities.
And reach out to your Emerson Impact Partners, depending on where you live, and they would be more than willing to get you with the right people so you can survey your equipment and help out with that.
Absolutely. I was just going to say we've got the expertise across our Emerson Impact Partner network and on also our network around the world to support some of that. So yeah, please, if you need some help with that, feel free to reach out to your local sales office or Impact Partner office, and they'll be happy to connect with them. Other question that came to me on the chat is it give a little more detail on how the savings calculation works, how the actual extra bleeding calculation connects up to the savings. I know you guys talked about the tool. Can you give us a little more details on that front?
So specifically on the savings, we would have to understand what the steady state vent rate is as a pre-post condition, and if it's measured, you may be able to quantify the savings as a full delta. We had referred to the use of instrument air or electric actuation as pathways to zero, and so in that case, then the total volume, including the actuator movement, will be part of the savings that are realized. So I can certainly go through some calculations. If there's follow-up, by all means, feel free to reach out to me and I can go through a specific example. It'll be control loop dependent as to what those contributions are. But often in a stable control loop, a lot of the regulations are focused purely on steady state because that tends to be the majority of the total contribution to volume.
So I think that helps kind of walk through. So you kind of do a before and after, and then we look at the delta there.
Yep.
Too.
Agreed. And here in Western Canada too, we do have emission factors that we can refer to. There's, of course, manufacturer published values. And I mean, there's some caveat with that too. Often they're published, like note for the DVC 6200, that is published for 20 psi and with a supply pressure of 80 psi. And so you may want to figure out, hey, what happens when I have a 6 to 30 control loop? And if I have, let's say, a 35 psi, and you can linearly interpolate that as well, and it'll be really close to what the actual vent rate will be.
Very good. Well, I don't see a whole lot of other questions. Laura, are you seeing any on your line?
I'm checking here. That's what I was looking at. Sorry, to see if I had anything. That was the one. There was a question, if we are running IA 99% of the time, but fuel gas is an option, do we still need to run low bleed devices?
I think that goes back to the question about instrument error and the impact of having, compressor time down. So I think there is still definitely benefits to low bleed, even if you're running instrument error the majority of the time. It just may be, instrument error may be less expensive. That's probably the case there, right, Brian?
Yeah, I agree. But if fuel gas is being used in service and we're dealing with a pneumatic control loop that is operated on fuel gas, then we got to make sure we're mindful of the regulatory compliance and that key value of 6 standard cubic feet per hour, 0.17 meters cubed per hour.
Yeah, that is all I'm seeing on my end here. So
Very good. I think if there's no further questions, we can go ahead and wrap up the conference. Appreciate everyone's attendance today. Like I said, this will be available here in the next couple of weeks on emerson.com. There's also a call this afternoon at 3 o'clock. If you have any colleagues that are interested in joining, feel free to forward them the link to register, and we'd be happy to see them here at 3 o'clock. So thank you, everyone. We'll go ahead and wrap it up, and we appreciate your attendance.